Here we go for my no-nonsense approach of the Eduqas/WJEC paper from summer of 2024. It's higher component 2, which means paper 2 to most normal people, which means for us it's calc aloud, so let's shut up and get on with it. For number 1, it's estimating the mean, but the data's been presented in a non-standard fashion. Don't forget, when you are told to estimate the mean, you need to multiply the midpoints by the frequencies. So that's where you need to be getting your information from. So first of all, you need to do, 5 times 75. Then you need to do 7 lots of 85. We've got 95 lots of 12. Gives us 1140. 11 lots of 105, 1155, and finally 10 lots of 115. Adding all those together, you get your sum to be 4,415, and you're told right at the start of the question that there are 45 students in the survey race, which gives you 98.1, etc. as your estimate of the mean. Let's move on. Factorising, standard quadratic. As soon as you see it, write down your brackets, single x's, and start making a list of numbers, pairs of numbers, which multiply to make -24, but add together to make -5. So do the usual, -24 and 1, and so on. And eventually you should get to -8 and +3. Simplify, or in other words, remove the brackets. Do your numbers first. So 3 to the power of 3. 3 cubed is 27. And h squared, all cubed. That's the situation where you multiply the powers. Inequalities on a number line. You need circles over, on, or above, or below -2. I always go for above. And 3. The one at 3 must be a closed circle, so shade it in. And you join them up, freehand or ruler. You don't need the arrowheads, but you can if you like. Number 3. Doesn't take a genius to realise triangle on a triangle means you're going to need to use some form of Pythagoras SOHCAHTOA, but it's definitely not a SOHCAHTOA because no one mentions any angles. Find the area of triangle BCD. Good news, we've got the height. We're going to need the base. Where do we get BC from? Onto your first triangle, it's Pythagoras. X is on the hypotenuse, so we're going to need to square root the sum of the two shorter sides squared and added, and as if by magic, it comes out at a nice number 9. And now you can just do half base times height. The area of the top triangle, a half, times the base, times the height of 4.9, and you've got your 22.05, and you move on. Good old standard probability trees. Each split must add up to 1. In it goes. Feel free to read the typical Eduqas waffle. I'll not bother. 0.75, 0.25, and there we go. Couple of marks. Calculate the probability on a given day. Does not eat a salad. That means we're going down there. But does drink a coffee. It's that branch. And and that branch only. There's no reversal. All right, you sometimes get the old find them winning one game, and that'd be win, loss, loss, win. Not here. This is one fixed scenario, and you multiply them. So 0.6 times 0.25, 0.15. Again, feel free to read the waffle. Each time it's reaching a height that is 55% of 55%. Your multiplier, therefore, is 0.55. It's not being reduced by 55% to make your multiplier 0.45. None of that. It's 7 bounces, power of 7, and your initial, your capital as it's sometimes called, into your calc, horrible long decimal 0.060897, and goes on, rounding it off sensibly. I've gone for 3 significant figures, 609 meters, 6 centimeters, and so on. I'll read out the assumptions. So the assumptions are that the ball bounces, in a straight line. If it was to hit a jagged edge, the angle of bounce would be affected. You could be, having a bouncing onto grass where it would bounce a lot less, going onto something more hard, a more tarmacy surface where its bounce would be more like 60% or 70%, and so on. So state any assumptions. It's always 55%, or in other words, the surface remains the same. For part II, what effect? Well, if it goes onto a harder surface, what's the effect? A harder surface would mean it retains more of its bounce, so it's going to result in a higher answer, whereas if your argument is a softer surface, it's going to reduce. So make sure you know which way round you get it to make your logical argument. Number 6, got 50 people. Get it banked. 27 take part in rowing, so that entire circle is 27. We can't fill it in just yet. 32 also can't fill it in, but there's 8 outside. That's the bit we do know. So also now we know the 8. These 2 circles must add up to 42. You can do it by trial and error. You could try a number in the middle and so on. You could call it x, giving you 27 minus x, 32 minus x, that plus that plus that equals 42. As I say, probably take you just as long to try some numbers. Let's try 10, making that 17 and that 22. Oops, that adds up to a number bigger than 42. So we need to increase, and eventually you'll get 17 in the middle. Whether you've gone the trial and error, trial and improvement way, or the algebra way, there's your final correct answer. Persons picked at random, find the probability that they take part in rowing, but not in cycling. That's those people there. They're the rowers who don't cycle, because those people do. It's 10 people out of the 50. Cancel it down if you want. They don't ask you to. Number 7, one of our typical, very, very wordy, but ultimately it's multiplying and dividing. So we've got £825. Our multiplier to convert it to the Brazilian reals, I suppose, is 6.27, giving us 5,172 of the things. It says only got 50 multiples of 50. So you can't, with your extra 22 odd, make up a 50 real note. So it needs to be rounded down to 5150. That means you can divide it by 50, which will tell you how many notes you can get. And it's 103 of them. Because it does say what is the maximum amount Abdul can buy and what will this cost him in pounds. So those 5,150 will cost him. Now we divide to convert it back to pounds. It's going to cost him 821.371 and so on. It's money, so we're going to round it off. £821.37. There we go. Number 8, transposition of formula, also known as changing the subject. We've got a cube root. Get rid of a cube root by cubing. So the P needs to be cubed. The right-hand side just becomes the RQ. If you want to make R the subject, you get rid of a Q. And this changing the subject is all about opposites. So we need to divide both sides by the Q. It's only a 2 marker, so it's only a 2-stepper. We're done. On we go. 9A, show means do and hope you agree. Expand the brackets. 14x squared times that, it's minus 16xy. That bracket, that loop, is minus 3xy. And the final loop, minus times a minus, is a positive 15y squared. Keeping one eye on the answer, you can see that they're there. The middle terms just need to be simplified. That means you agree with them, and that means you have fully correctly shown it. And the strange part B, explain why the identity symbol has been used. 2 possible answers. Again, I've done these on my work solutions. Feel free, I've wrote them out as an examiner here. I always just read through. I'll do the same for the circle theorems question coming later on. But the simplest way is, it is always true. But if you want to expand on that, simply say it's true for all values of x and y. And that's it. Yeah, there's 4 dotted lines. You don't have to write anywhere near 4 lines or 4 sentences. For obvious reasons, on number 10, I've had to cheat. So the idea is your first job to be equidistant from AB and BC. That's your angle bisector. So set your compasses to a sensible size, metal point on B, and you draw, I drew this arc here. This arc there. Lifting up my compass, metal bit on here, arc, metal bit on here. Those arcs cross, joining up with a ruler to your vertex. You get a couple of marks for your angle bisector. Now you need to do a perpendicular bisector for B and C. So if you're like mine, you've drawn them a bit confusingly, you've got to just try and park it, ignore it. Don't rub out your arcs though. When you're drawing a perpendicular bisector for B and C, that's the technique where you set your compasses over halfway and you draw your semicircle from one end, kind of a semicircle from the other, and when you join up the points they cross, in goes your perpendicular bisector, and where they intersect is where we get D. So obviously it's bound to get a bit complicated, confusing, but don't be tempted to rub out your arcs. Number 11, I say good old pressure, force and area because they're nice, folks. Don't be put off by these. You've seen them in science. They love the clip art. Forget all that nonsense. It's a circular base. That's what it's all about. What force? You need to rejig this slightly. Force, we need to multiply both sides by area. So force is given by pressure multiplied by area, and on we can crack, because we've got the pressure, 0.97. We just need the area. The area is a circular base, as mentioned. It's pi times the radius squared. Stick all that in your calc, and I'm getting 1755.27 whatever. Sensible. I'm going to call it nearest whole number. On we go. Number 12. Waffle, waffle, words, words. The only thing that really matters is you focus on right angle triangle, and we care about where he stood, distance from the base of the cliff. That's it. That's your focus. Now crack on and find x. So 35 from the 72, 35 is on the opposite. The hypotenuse is unnecessary in this question, and x is the adjacent. It's a TOA question. And we are attempting to find the adjacent side, which is x. So x is given by O for opposite is 35. T for tan of your angle. Sticking that in your calc, you get 11.37-ish. You don't have to round it off, because as long as you've got a number like that appearing on your page, and therefore Pierre is safe, because he is more than 10 away from the cliff. Number 13. Lots to write out here. I'm not going to do it all, and nor do you. Trial and improvement means try a number and on you go. Again, I've done it a bit better on my worked answers, so if you care, go over there and see what happens. Best to make a column for x. Being told that the solution is between 2 and 3, you've got to go 2.5. Sub it in. Use your brackets on your calc. Fortunately, it's not a negative. And you should get your output to be minus 4.25-ish. That means, because it's below, it's too small, I went to 2.7 next. And my output was positive, 2.866. So for obvious reasons, I go back down a step, 2.6, which then takes me back into the minuses. In other words, too small. We can now eliminate 2.5 from our answers. We've got it between 0.6 and 0.7, so you chop it in half. 2.65 is an absolute must. You won't get full marks if you haven't attempted 2.65. Output, if you do it correctly on your calc, is 0.969-ish. Again, and so on. You can stop there. You don't need to do any more. We know that 2.65 is above 0. In other words, it's too big, which means the answer must be smaller, or to put it in inequalities, the correct value of x that we're after has to be smaller than 2.65, but bigger than 2.6. So it could be 2.61, 62, 63, 64, whatever. It doesn't matter. They all round off to 2.6. So that's enough trials. Don't go wasting your time trying any more. All the numbers like 2.6, 2.61 and so on. It rounds off to 2.6. You can stop. Very easy to overcomplicate and waste time on those questions. Don't. Number 14. The denominators, they're all factors of 6. Times everything by 6. Now you could do it by 2 and then by 3. Waste of time. Just do it by 6, which ultimately means on the first term, the 2 is going to cancel, so you're just going to end up trebling what's on top. Over here, the 6 and the 3 will cancel, meaning you end up doubling what's on top. And the 5/6 times by 6, done. You've got it on a level, you've earned a mark. Let's crack on with expanding, simplifying, and ultimately solving. 12x's plus 15 minus 2x's minus 2. Collect our x's together. We've got 10 of them. 15 take away 2 is 13, but I'm going to subtract 13 from both sides. And we can now divide both sides by 10. So minus 8 over 10 or minus 4/5. I'm going to go for the decimal equivalent. Number 15, we have a solid cone. This is one of those where you feel like you might not have enough numbers. It doesn't matter. Just get on with it. It's a solid cone. You're asked about density. If you refer to your write it anywhere. D, M, V. If you want density, you don't. If you're wanting mass, you're going to need to do density times volume. Let's do volume then. Volume of a cone is 1/3 times pi times the radius squared, or the radius is y, times by the height. The height is 6 lots of the radius. As you can see, there's a pi in the answer. There's a y cubed in the answer. And the 6 and the 3rd simplify to 2. Well, even easier, as you can see, mass will be density times volume. We've got the volume. We're told the density is 7. Just work out 7 2s. But yet, one of those questions that seems a lot worse than it actually is. On we go. I've cheated for number 16 to save yourself time and to save me from looking stupid. We have a cumulative frequency curve, that's for the 10-year-olds, and down the bottom, box and whiskers for the 14-year-olds. I'll stay on this page. I'll come back to it though. In fact, I'll come back to it. Lewis says 14-year-olds spend longer on average. Well, whenever you're doing these, you've got to check the median. So the 40th student, we go along and down, is there. It's on 60. Whereas for 14-year-olds, that's your median, and that's on 74. There's your comparison. Is Lewis correct? Yes, he is, because the 14-year-olds on average spend 74 minutes, and the 10-year-olds on average spend 60 minutes. Any sentence to that effect, and you're good. Part B. I is easier than you think. Percentage of 14-year-olds who spent less than 40 minutes. Well, 40 minutes is actually the lower quartile. Quartiles does exactly what it says on the tin, quarter. There is 25% of the students lower than 40. No calculations required. Just a little bit for the next. The percentage of 10-year-olds that spent more than 120. Back to your graph, back to your cumulative frequency. Circle your 120, go up and along. We get 76 students. In other words, only 4 spent longer. That's the key. So 4 spent longer than 20 odd minutes. That's 4 out of 80. That's your fraction. Stick it in your calc and times it by 100. We get 5%. Part C, compare the interquartile range. Back we go. For the 10-year-olds, interquartile range, I get the upper quartile to be 84, the lower quartile to be 40. So your interquartile range, subtract them to get 44. That's for 10-year-olds. For 14-year-olds, it's a bit easier. You just need your upper quartile, which I read as 116. So there you go. Your interquartile range for 10-year-olds is 44. Your interquartile range for 14-year-olds is 76. A larger interquartile range means there's more. It's more varied, more sporadic, more spread out, or you can take it from the 10-year-old's perspective and say that they are more consistent. There's less variance, there's less spread. But you earn a mark from those numbers, so there's only a mark for a little sentence connecting the two. So again, do not waffle. Number 17, I've got to say, straightforward maths, not the straightest of concepts to get your head round. So the idea is Noah takes a shot, Jenny takes a shot, Noah takes a shot. In other words, they've only got one target. So it's the order that's important. Calculate the probability that Jenny wins the game on her first shot. For her to win, Noah has to miss. Then she has to hit. Stick it in your calc. Calc cancels it down. So as I say, maths-wise, easy. Concept on what's going on, not so straightforward, but hopefully I've got that across. Calculate the probability that Noah wins. And again, what we're doing here is basically probability trees, but without the nonsense of having 8 end branches. The branch, the thing that would happen for Noah to win the game on his second shot would mean he has to miss his first shot. Then Jenny must miss 7/10. Then he must hit. All right, and then on your calc, 14 over 125. Easy when you know how, but not, as I say, not the most straightforward of concepts. Number 18, errors and bounds. You've got 3,000 meters, correct the nearest 100, so stop. If you've rounded continuous data to the nearest 100 of something, you go up and down by half that amount. 50 for this. Seconds is also continuous data, but this has been rounded to the nearest 10, so we're going to go up and down by 5. Calculate Kian's greatest possible average speed. Speed is distance divided by time. Once we've got that, if we want the greatest possible speed, we're going to need to pick the biggest possible distance, but the lowest. We need to divide by the smallest value for time. That's 3050 divided by 715, 4.2657, and so on. I'll call it 4.3. And there we go. Easy once you've set it up, but you've got to follow the logic. If I want the greatest, which of those numbers shall I pick? Number 19, yep, I've cheated, but I'm not a big fan of using the ray method. Okay, what I am a fan of is plot the centre enlargement, 1 along, 2 up, and do everything by counting. If you've got a scale factor of -2, any movement right will become left, and it will double. So I pick this vertex, right 1, up 1, becomes left 2, down 2. And that's it. Pick another one from the centre, right 4, up 1, becomes left 8, down 2. And treat it as if it's a posh dot to dot. Then you use the rays as a way of double checking. Use a see-through ruler. Do they line up? Do corresponding vertices line up? I think it's fair to say you can check them all if you want, but mine certainly do. So I'm just going to take the couple of 3 marks and move it on. Number 20. It says give a reason, as I always do. It's written out fully on my worked answers on my website. Go and check them out if you want to. Here, I just voice them. Firstly, that angle is 66. The angle at the centre is twice the angle at the edge. That's your first reason. Second, that angle and that angle are both 90 degrees because tangents meet radii at right angles. Final reason, angles in a quadrilateral add up to 360. This angle, you do 360, take away the 2 right angles, take away the 132, and hey presto, you get the 48 that you were asked to show. Number 21. To simplify these, it's always the case that you factorise them and stuff cancels. The numerator is our old friend, difference of 2 squares. Everything, the 4, the x squared, and the 25, they're all square numbers. So it's 2x and 2x plus 5 and minus 5 on top. On the bottom, not as complicated. They're both in the 3 times table. They both have an x in. And when you factorise out a 3x, you're left with a 2x and a -5. And bosh, they cancel. So final answer is 2x plus 5 on top, with or without brackets, no one cares, and 3x on the bottom. Number 22. Not the worst kind of these, so stick with it. The line you are given has gradient next to x of a half. So the gradient of the perpendicular, you need to do negative reciprocal, or in other words, flip it and change the sign. A half flips to be 2 and becomes -2. The equation of this straight line will be y equals mx plus c. Y equals, whoops, we know the m. That's what we did, Al. Come on. What we do need is the intercept, the c. The information we have been given. If you replace y with 5, you can replace the x with -1. -2 times -1 is +2. Subtracting 2 from both sides, you have your intercept, which means you have your equation -2x and 3. Don't celebrate yet. It wants it equal to 0. We need to add 2x to both sides, subtract 3, and there we go. We've done it as we've been told to. Number 23. Follow the logic. If you want to work out the length of YZ, that's that there, you're going to need to know a bit more information. Normally, when you have two triangles back to back, it's all about finding the side that they share. But we already know that. So it must be a bit more about, and yes it is, we need this angle here. That angle and this angle make a straight line. I'm going to call this angle X because we know 61 and 13.1, they are opposite to each other. When you have a non-right angle triangle and you know an angle and its opposite side, it is a sine rule question. So we can make the statement that sine of 61 divided by the opposite side equals the sine of the angle we'd like to know divided by 11.8. We multiply both sides by 11.8. When you stick all that in your calculator, you are going to get a horrible decimal that hopefully begins 0 point something, because when you want an angle, your job is to inverse, shift or second function all that. So whatever decimal you get, inverse or shift sin ANS button is worth its weight in gold. We get 51.98 degrees. Feel free to call it 52, but whatever you do, subtract it from 180, because that's what we needed. That angle there is 128.02. Now your entire focus is on this second triangle. Feel free to redraw it, but hopefully you spot, you know an angle and the two sides either side, making this part a cosine rule question. The opposite side, which is YZ, YZ to the Americans, and if you look it up, it's a squared plus b squared. I'd just rather say it as it's the two sides either side of the angle squared and added minus 2 lots of these sides multiplied by the cos of the angle between them, 128.02. All that on your calc should be giving you 358-ish, which does need square rooting 18.93-ish. 18.9 will do for now. Number 24. The relationship, don't forget, between linear scale factor and area scale factor is when you double a length and you double a width. If you double it and double it, it's actually quadrupling it. Or in other words, doubling, which basically is you've got to square your scale factor. For that scale factor, your multiplier, well, it's getting smaller, so we need to do 10 over 16. It cancels down to 5/8. 5/8 is your linear scale factor. Large horse, surface area is 640. For the surface area of the smaller horse, you need to multiply by the linear scale factor squared. Happens to give you a nice number. Surface area of the small horse, 250. Well, we're now into the final phase. We want the total surface area. There are 50 small horses, 50 lots of 250, and there are 30 large horses, 30 lots of, 640, gives us 31,700 centimetres squared. Each can of spray paint covers that much. We need to divide by 9,300. That's 3.4 cans. You can't buy 0.4 of a can. Holly's going to need 4 cans, which will cost 4 lots of £8.45. 33.80 for her total cost. Take a deep breath, on we go. Number 25, I would argue, is one of them that either you see it or you don't. If you don't see it, rock hard, virtually impossible. If you do see it, you'll find it quite easy. I've drawn on the radius of the circle. That means you get a right angle there because it's tangent and radius. What else do you get? You also get this going on. It is an isosceles triangle. It is symmetrical. The distances are the same. It's going to be a bisector. If A and A are the same number, if A was like bigger, if this was 9 and that was 7, not true. But it's equal. It's isosceles. That was 90. It's chopped it in half. And so on. I could give you 101 ways to think about it. But ultimately, the radius of a circle, that distance, is the root of 32. Because it's isosceles, so is that. We're just going to apply Pythagoras. Square that side, we get 32. Square that side, we get 32. The longest side, add them together, 64, and you square root it. So the distance from 0 to A is 8. In other words, A is 8. Easy when you see it. Very, very difficult if you don't. Lots to number 26, as I always do. I've drawn it, well, I actually cut and pasted it from my worked answers, so it doesn't take as long. Part A, calculate in kilometres per hour the velocity when t is 4. Get a ring round it, up you go, along you go. We get 24 metres per second. That's not the answer. It wants it in kilometres per hour. To go from seconds, metres per second, minutes you can travel 60 times longer, hours you can travel 60 times longer. But going from metres to kilometres, you need to divide by 1,000. So hopefully you can do that in any order, but hopefully it's times by 60, not divide. Hopefully times by 60 twice, and hopefully you've divided by 1,000 and not multiplied. 86.4 is the correct answer. I'm not going to move on. Part B wants an estimate for the acceleration when time is 2 seconds. So your job is draw a tangent, get a see-through ruler, draw a large tangent, not a tiny one. If you've tried to do it like too small, start again. Look at how large mine is. I'd say from there and even bigger if you want to, but I think mine's about right. It makes it much easier if you end on big lines to find one of the measurements. So that's why I picked that size, because 25's dead easy. Count the squares and so on. I got 8 squares. Each square is 0.2. 1.6. And that means you've got enough for your calculation, because acceleration is the vertical, the height of this triangle, divided by the width of this triangle. Your teacher will call it changing y's over changing x's. It's all good. The mark scheme does not specify an answer. So I will just say that that's what I got, because the mark scheme's all about you get a mark for a sensible tangent. Make sure it's large enough. A mark for finding two numbers and dividing. So it's actually reasonably generous. On to the final part. It wants us to estimate the area. It says the distance travelled. That's area. As you can see, I've chopped it into 5 trapezia. You just need to read off the heights. 24, 21.5, 17, 13.5, 14.5, and 18. Make sure you've made a note of those, because your job is now to find the area of all those trapezia. So for A, all of them will involve, by the way, halving and timesing by the distance between them. That'll just cancel, so I'm not going to be bothered. So it's half times 2, in other words 1, and it's the heights added together. So B will also be 1, in other words a half times 2. And the 21.5, there'll always be duplication, don't forget, because each height in the middle will be utilised twice. So it'll be 21.5, and I said 17. C will be the 17 and 13.5. D will be the 13.5, and it goes up again, 14.5, and E would be a half times 2 times 14.5 and 18. I forget what the mark scheme says, you're allowed a bit either way because of the 0.5s and so on, but the perfect answer is 175. On we go. Number 27, when you're finding points of intersection, it just means sub it in. An easy, nice one is, no need to rearrange, just take the equation, and where you see y squared, replace the y with x minus 3. And as with all these questions, expand brackets, collect like terms, and so on. We're going to square the first, square the last, times them together and double it. We'll now times that bracket out, in other words, double everything. I'm terrible at these 8s. Minus 12x minus 12. I'm taking that away from both sides. Get everything simplified. Equal to 0. There's a clue. To give your answers to one decimal place, that's a nudge. You need the quadratic formula. A is 5, B is negative 12, C is 6. So it's minus B, it's minus of a minus, that's plus. Don't try and do it all in one go on your calc. It's asking for mistakes to be happening. B squared means negative 12 squared, that's 144. Minus 4 lots of A is 20, times 6 is 120. So the square root is just 24. 2 lots of A. And I always like to split my page in 2. One value of X, it wants one decimal place. One of your answers is 1.689. That'll be 1.7 then. And you've got a nice equation. The y coordinate is equal to the x coordinate minus 3. 1.7 minus 3. So the y coordinate is negative 1.3. One of our other answers, why I'm underlining so it looks like a fraction. One of our other answers is 0.710. In other words, 0.7. And our y coordinate is the x coordinate. Take away 3 minus 2.3. And because the question was set up as coordinates, give your answer as coordinates. The first pairing, 1.7 and minus 1.3. The second pairing, 0.7 and minus 2.3. So I've got to say, overall, a decent paper. Certainly 3 or 4 tricky ones towards the end, that circle question in particular, but don't get put off by them. They're only 3 marks. There's plenty of other meat left on the questions earlier on to get a decent grade. Anyway, hope that's helped. Hope I kept the waffle to a minimum, and see you on the next one.